Hey everybody, Jim Dave here again. Hey, yesterday I posted a video on how to use a standard milling tool and Toolpath to create laser uh, G-code files on Vectric Vcarve Pro, but Aspire's the same. And today I got a comment on the video from a guy named Mike that said, "Hey, can you do you know if that works with the new Quick Sketch Toolpath?" So on version 12, Vectric came out with it's kind of I would say like an artistic sketching toolpath. You put in either a bitmap file or a picture. You just upload any photograph you have, or it also works off of 3D images, like your carvings and stuff. And basically, what it does is tries to interpret that into kind of a simple sketch looking thing, so that it's not super detailed, but it's kind of artistic and it looks cool, and it really does a nice job. You can take a photograph and it kind of highlights the backgrounds, and you can actually tell what the person and stuff. It's got pretty good detail in it, but it's kind of neat because it's one of those really simple things to run. I haven't played with it much yet, but since Mike asked, I thought, well, let's see so today I pulled it up, and I just got done running my very first run on this, and let's turn the camera around and take a look at it. So here's the finished job. This took about an hour and a half or hour and a quarter to run. As always with the laser, you can expect it to run a little longer because these lines are a little fatter, and with a V-carve, it would just drop the bit down so that the bit can touch both sides of the boundaries of this line. But with my laser, since that's only about 7/1000ths of an inch wide, it actually has to go back and forth quite a bit to fill this in. So it takes a little bit longer, but hey, it looks really great. This looks exactly like it would look like with a V-carve bit instead, but with the V-carve bit, you'd have to have the additional step to paint it and everything. So if you just want a black image on whatever substrate you're doing it on, the laser is perfect because it has very high detail. You don't have to paint it or anything. So this, I literally just blasted onto a piece of MDF, and it looks great. This is very typical of what I've seen of all of Vectric's tutorials on this new toolpath. This is kind of the typical image you get from it. But I had to kind of figure out what kind of tool to use and stuff, because there's no laser support for it in Vectric, and there's no end mills. You can use a ball nose, an engraving bit, a V bit, and a tapered ball nose. Those are your four choices of different kinds of tooling that the toolpath will accept. So I modified the engraving tool bit for the laser, and then I used the post processor that I talked about in my last video, and I didn't have to make any changes, so this worked great. So let's take a quick look at how I set all of that up in case you're interested, and I'll also down in the description section put a link to my Google Drive where I have the post processors for Vectric. This is the same exact post processor that I used in the last video to make some laser images off of just a regular end mill toolpath, a profile or a pocketing toolpath. So to answer Mike's question, yes, this works very well. So let's get into it and take a look at how to do it. Well, the first thing we need to do is create a tool for this project. And I also just realized why a couple people mentioned in my last video they couldn't see the windows when they popped up when I was creating the tools and things like that. I apologize for that, and I figured out why it wasn't recording the pop-ups, so hopefully you'll be able to use this one to kind of supplement the gaps from the last video, because it's really the same process. So we're going to create a new file first. 10 by 10 inches seems like a good size so for a demonstration. So and then with the laser I always use the material surface, and center of the picture seems to be good. So we're going to do that. So now we got our picture, or our frame here of the material that we're going to work on. And over here on the right, you can see this is the new sketch carving toolpath. And this lets you use a V-bit, a ball nose, a tapered ball nose, and a engraving bit, which has kind of a special tip profile. So when I looked at all of these, I think the engraving bit has the best. It's the best one that we can modify to represent a laser beam. So we're going to go into Toolpaths and to the tool database here, and I've already created it, but I put it under specialist laser engraving here. But just to show you how you would create a new one, you would click on, say, if I want it to show up under specialist, and then I would hit the plus button here, and that'll give you this kind of first half of the tool up top. It's blank, and I'm going to say engraving bit. So that kind of sets up what style of bit this is. And I'm also gonna name it, you can, it changes the name that goes up in the menu here, so it's kind of nice. So I'm going to call it laser engraving 45 watt opt. So that's my I have several different lasers, so I usually make a tool for each one. I do not want to make this the default for engraving because it's kind of an oddball, and I don't want to modify the others, so I turn both of those off. So now we've got a title that's going to show up down here. This one's a test. You can see this other one, I actually put the kerf in there. Sometimes I should do that just because it's a nice reminder of how big it is. There. Okay, now I can write any notes you want here. We don't care about that. The tool type is important because if I didn't select one of the ones that tool path will accept, then when I try to put a tool into that tool path, it won't even show up there. So that's why we picked the engraving one. I work in inches. The diameter really doesn't matter. It does need to be bigger, I found out, than the actual diameter of any of the diameters down here. So I just put a 1/4 inch shank in, that's fine. Now what I'm going to do is use this little flat part on the tip to represent the laser beam, and I'm going to ignore the rest of this. So to make the rest of this stuff minimal, I'm going to make the angle as small as I can. So basically this is like a super fine, almost straight wall. 1 degree is the smallest number. If I try to put like 0.1 in here, I don't think it'll let me. Actually it did. No, when I use the up and down, 1 is the smallest it'll let me put in there, and that's 1 degree is fine. The flat diameter, that's my actual diameter of my laser beam, so that is important. The flutes do not matter, but I'll just put 1 in there for the heck of it. So that's the stuff that needs to be filled out there. Now you can create settings, and the rest of this gets filled out. And so on the pass steps, this is gonna be single pass, and I am going to set it very thin. I don't want to put 0, even though 0 would be okay for the laser. If I put 0 in here, then the simulation, because it still thinks it's a end mill when it simulates this, if I don't put some finite depth there, it'll simulate with a 0 depth cut, and it won't show up and you won't see it. So I just put 1/1000th or 1,000th of an inch. That won't change the focus of the laser significantly or anything, but it allows the simulation to run. I'm going to do a step over to fill of
just a slightly smaller number that gives me a good overlap, and so it'll fill in nice and black. And I'm going to do the same thing with the clearance. So with the laser, you don't overlap like 50 or 60% like you do with an end mill. You just want to butt up the edges so you don't have any white lines between them. So usually I just make them about the same size or slightly smaller than the actual laser beam. The spindle speed in RPM. Now this is your actual power setting. So the post processor is going to take the RPM and convert it into power into the power command. So this value has to be between 0 and 100. From this laser, 8 RPM, which is 8% power, is pretty good for engraving at 50 inches per minute that I'm going to use. The chip load is something you can just ignore that, and the tool number, I always use lasers as 1. So that's good. We can apply it, and we see actually I have 2 of them here now. So I've created both of those. I don't really need that second one, but I just put it here for demonstration purposes. So that's how you create the tool. And if I were going to do an end mill, it would be similar from the other video the other day that I didn't document very well because I wasn't recording the pop-up windows. You would go in there, say in your end mills, and actually you could I put mine in my specialist here, but here's my laser end mill. And basically, just like before, I clicked on specialist and I hit the plus and it made a new one. And this is what that looked like. But in this case, for just standard pocketing and profile cuts, I made a laser end mill, not a laser engraving bit. So I used the end mill selection there. But all of these other parameters are very similar. I'm going to use spindle speed for power again. I'm going to set my my diameter to the diameter of my laser. I'm going to use the same diameter for step over, blah blah blah. So very similar process. So in case you missed that in the other video, this is what that tool looked like. Okay, we got the tools. Now let's go look at importing the picture and creating the toolpath itself. All right, let's make ourselves the actual project. So we've got this 10 by 10 workspace here. We got a project started. So let's go import the picture itself that we want to use. So we'll go into import, and in this case, it's a bitmap, so it's in with the vectors and stuff here, and we get a pop-up, and I know my picture is in this directory, and I'm going to use this little doggy picture here. So I'm going to import that, and so it's imported this bitmap in here. If I was really doing a nice picture of this dog, I would have gone and I'd added out this leafy plant and some of this stuff here just to get the dog. This one was one I had edited before and took the background out of, but didn't get quite everything fixed. But it's good enough for here. So I'm going to leave that like that. Now, one thing to note is this toolpath, when it runs across the bitmap, it will actually make lines out of the border here. Like you can see when you select the bitmap, you get this border, and the toolpath will make it'll make that actually part of the border of the image, and I don't want that. So I just want the dog part. So a way around that is it lets you constrain the boundaries by a vector. So I'm going to put this box around it here just to kind of give it some constraint when we go make the toolpath. So that's all we have to do for the importing part. You just bring it in like you would for other kinds of bitmaps when maybe you're going to trace it or something like that. So we got that. Now let's go pull up the toolpath itself, and this is the new sketch carving toolpath. We have a choice of a bitmap or a 3D model. In this case, we're working off of an image, so it's bitmap. I'm going to start at my Z0 start depth. I'm not doing this down in a pocket or anything. It's right at the surface, so I'll leave that at 0. I am going to set my flat depth to 0.001. So basically, I told in the tool, if we go in here to select a tool, you can see it already had that one selected because the last time I played with this, it pulled that in. So it was the default, but I already said my pass depth is 0.001. And in this case, I'm gonna have it cut at 00 or stop at 0.001 as well. The reason for that is it's not an end mill, it's actually a tapered bit, and this Toolpath basically tries to do V-carving with these kind of bits. All of the bits that are allowed for this have a tapered sidewall, so it tries, it draws lines, double lines essentially, just like if you're familiar with V-carving, and tries to Z down the bit far enough so the sidewalls of the bit touch that. Well, we have to constrain this. We don't want that to happen. So what we're doing is we're picking the bit of all those choices, the bit with the straightest sidewalls, and we're using the flat tip on the bottom as our beam, and we're purposely not going deep so that the sidewalls are very close to the line. So it's kind of a neat way to fake it out and just use something that's essentially got straight edges in a tool that doesn't like to work with straight edge tools. So we've got that selected. We're going to use the bitmap selected vectors. That's the limit boundary. So that's what I was talking about there. It will ignore. I have to turn on and select the bitmap here, and I also have to select that boundary at the same time. And you can see it already started, or essentially created the sketch. And it's not going to do these dashed lines on the very outside because I constrained it by this boundary of the box. So now you can fine tune this thing. You've got this slider that lets you make essentially thicker lines. The tool is looking at the image and trying to sketch features around it so that it kind of looks like the image. So it's looking at the colors and the shapes here and stuff and trying to sketch in some lines. And so your job with the slider is to kind of move it around until you get the best looking image. And the fatter side, in this particular case, the fat ones don't look very good. We want to get down to something with a little whoop. Now that got so fine that I lost resolution on it, so I don't want to. So probably about there is good. So now we have the green essentially is all your sketch stuff, and I've also got the plant in here, so this dog's gonna look like it's got a little bit of a deformed foot, but that's okay. This is just a demonstration. So we're gonna calculate that toolpath, and it's essentially turning all of this green stuff into vectors, and now it's displayed that, and so we can preview that. For laser, I like to make the toolpath color black, so we're gonna set that to black and preview it. There you go. So that looks pretty good. On the actual one I burned already, I made this a little bit heavier lines, but this looks pretty good. So that's it. Now we just need to actually save this off. Well, now we've got the toolpath made in the Vectric file. We just need to make our G-code. So we're gonna close the image preview and select our toolpath. Now you can add other toolpaths too, like you could add a V carving in, you know, for some letters like your dog's name or whatever on here. You can mix this in with all kinds of other things. So you can, you know, make a big sign or something or plaque with one of these sketches on them and then combine it with a whole bunch of other carving stuff. So it's pretty cool. But we're just going to save this one, and this is the toolpath. This is the same exact, or not toolpath, same exact post processor that I talked about in the previous video, where I did profile or pocketing toolpaths to make graphics with a end mill laser. So I use this, I call it spindle to laser. And as I mentioned in the other one, the no Z means that it's got the Z movements disabled. So I did not project this onto a model. And in fact, oh yeah, you can. So that's a cool thing too, is you can actually do this sketch on top of a 3D model if you want to. So that is an option I forgot to mention. So if I were actually doing that on a 3D model, I would need to pick the one with Z here, because that would allow Vectric to output Z movements as well. Or I shouldn't say allow Vectric. Vectric's going to output them, but the post processor wouldn't put them into the G code. So I'm going to use the no Z one here, because I know I'm doing this on a flat surface. I'm not projecting it on a model, and that is much, much more efficient. It doesn't have to move the laser head up and down for anything. It just stays flat and does its thing as fast as it can. So we would save that, and we're done. So that's really, yeah, it's very simple. And that's why that was the whole point of this new toolpath that they designed and put in to Vectrive 12 is in the past, to do V-carves of pictures, you had to do it off of a bitmap or something. You really couldn't. You know, you could get a silhouette or something like that and do a V-carve, but what this really does is almost kind of creates that silhouette from a bitmap or from a model, and then it lets you adjust the qualities of it with that slider. So it's really cool. I think it's a lot of people seem to really like it that do signs and stuff, because it's you know, time is money, and it allows them to make a pretty neat little image that's appropriate for a sign, because you could see it from a distance. You know, if you made it bigger, they make nice plaques and stuff like that. So now to be able to do that with a laser is also pretty cool, I think. Even though Vectric didn't really intend, they didn't advertise this, that you could do this with a laser as well, and their laser module doesn't support this at all. It is possible to do this just with a little bit of a workaround here. So anyway, that's how you generate the file. So thanks for watching. If you have any questions, put them down in the comments sections. I always answer them. And if you have any other suggestions for videos that might be helpful for you, I'm open to that too, so put them in the comments. And I do have in the description section links to the previous video that's sort of related to this, as well as my Google Drive, where I have all of the post processors that you can copy down and use if you'd like. All right, thanks for watching.